Hello, I'm Luke Mateo, and I will be doing Project 1. So open up Fluent, open up a new design. And this is my second recording. The first one got Fluent crashed, so that's great. So we're gonna go into units, inches, because that's what's given in, zoom out for the correct scale. I did 300 the first. No. Be around here. Start the sketch. 1, 2, 3, 4. So then we're gonna define it. I don't know. Yeah, well, we're gonna have some problems here, I think. Maybe this has to be 24. This has to be 12. This has to be 42. Whoa. There we go. So once that's done, I'm gonna just start this now before I forget. We're gonna center this. So put a construction point on the origin, then draw a line tip to tip, and then go to relate or constraints, midpoint, select the line. Then we're going to select the origin. So now it's centered about the origin. Then we're going to draw vertical lines for like the chambers. This is my second time doing this. Actually third time doing this. Let's see. Then we're going to first one do constraints, midpoint. Okay. And then we're going to define the lines. The first one's 22. If I can find, there we go, 22 inches. And the second one, same thing, 22. Okay, yeah, I'm recording, just making sure. And then, am I sure? Yeah, okay. Again, continue to define. This is 6 inches. This is 6 inches. Nice. The rear one is not, we call it defined because it's defined by the angle and the length. So you could define it. You could solve whatever making it a right triangle and solving it, but I'm not gonna do that. So then we're gonna draw. Basically, just gonna connect the dots. Okay, so this is a problem. See with this parallel relation? If we do that, it's becoming parallel with this line, and we don't want that. So we're gonna undo until that line's gone, and we're gonna you have to do that to select a line. Delete this line. We're gonna make it small and do the midpoint again. If I can find constraints, yeah. Midpoint. So now it shouldn't do that. Yeah. I think it will. Because if it is parallel, there we go, that's great. If it is parallel, it will throw an error because it'll be overdefined. So just keep that in mind. Angle, zoom in here. We want these two angles, perfect. We want it to be 93 degrees. Yep, and it automatically defined the other angle too. So now we got that done. We're gonna draw. We're gonna delete all the lines that aren't necessary. So like this line, this line, this line. Leave the rear and the front, the middle line, and then this line, this line. Yeah, this line, this line. Now we kind of have a what do you call it? I forget what we would call that. Then we go to concepts, surface from sketches. This is the surface. Apply. And then generate. Yep, that's correct. Okay, great. And then since we have this, I'm gonna save this because I had an issue where I was recording this and the program crashed. So we don't want that to happen. And if it does, I don't have to restart from scratch. So if you're doing this project, take my advice. So then we're gonna open up the mesh. That's if it opens. There we go. This program is very I don't want to say buggy, but it kind of is. That's a heads up too. Then after we got it mesh or bring it in the mesh, what are we doing? Always forget this part. Oh, that's right. We're gonna actually, are we still in the sketch? Yeah, we are. Are we? Yeah, we are. Is this the? Yeah, I think this is it. Yeah. What is this? Okay, yeah, that's sorry. We're gonna update. So there we go. Then we're gonna hit insert method, select the surface, apply. We want triangles. I think that's it. Sorry, the meshing one, I always forget what you have to do. Yeah, and then hit generate. If we the mesh. So now we have triangles, but we got to go back. Oh, and this has to be in inches. I always forget that. And we want the element size to be 0.2. Up or generate. Generates basically the equivalent of like up or rebuilding in SolidWorks. We have a very fine mesh, as you can see. And then we're gonna start defining the edges. So hit this. This is like this selects maybe. Yeah, it's selected. Just me. Selects edges. Right click. I didn't select it. Create name selection. Selected. This is gonna be velocity inlet. this is gonna be the pressure outlet. And then we're gonna hold control, just like in SolidWorks, and then right click, names, and this is wind tunnel walls. And then after this, I believe we're moving on to the actual fluent part that we can confirm. So then we're gonna go back out. Re-update the mesh. I'm gonna save. What am I gonna save? The mesh, right? Right. Just in case, again, I don't want to redo this video again. This is where I got to last time. Then we're gonna set up double processes. I think that just loads everything faster because most processors are quad core. I think that's what it's doing. Okay. So it's giving me a. Let me figure this out. Okay, so I figured out the error. Not a big deal. It's just the licensing is a student. So, if you have two workbenches open, it won't. It's thinking that you're using on multiple computers because it's a free license. Makes sense, but it's kind of stupid. So to resume, hit setup to start, and I think it's gonna open on my other monitor. Yeah, it is. I'll try and drag it over as fast as I can. Here we go. So just let all this load. Like, so there's the model. Yeah, that's that. And then where do we go for? Okay, so then we're gonna go. I'm muted now. Go to, we're gonna turn energy on. That's right. I think that's under. Where is that? What's that under? Models. Energy on. Viscous thing. K epsilon. Enhanced wall treatment. Pressure gradient thermals effect. Okay. cell zone conditions, fluids, and that up. No, sorry. All right, yeah. So then we go to boundary. This boundary conditions is where you change the So like the velocity inlet when you click it. Um, I don't know why it did that. When you click it, this is the velocity that you need to figure out. Um, given the v test speed, you need to figure out what the magnitude of the velocity on the inlet would be. And when we did it, when I did it mathematically, it would give you when you ran this simulation, it gave you a smaller value. So you need to do, you kind of have to play with the number to get what your v-test should be. And I found out that number to be 0.64. And go to pressure outlet, so apply, close, outlet. Thermals. I think you can just leave this as 300. Yeah, we left as 300. Wind tunnel walls. Alright, sorry, and their reference values. Enthalpy is 27,000. Yeah. Let me make sure that went in for the velocity, because that shouldn't match. Wait, I'm gonna change this. This should be. I don't know why it's not updating. And then we're gonna initialize. Where is that? So before every, so when you're changing your the inlet velocities, every time you have to initialize. And we're done. Then run calculations. Now the running the calculations. I don't know why that. How did it do that? Ah, that's why. Because we didn't put the iteration numbers. So it like finished instantly. So now we just wait for this to calculate. And then next well, what we're gonna doing is creating the graphs. That's the whole point of this. And we have to make the contours too. Okay, we're done. Thank God. So then we're gonna go to contours, maybe. Under plot, no, it's not under plots, graphics, contours. Pressure, static, pressure, select, I hit Control A. Oh. Here we go. So we want static pressure. So this is static, dynamic. And then I think we wanted dynamic. Oh, we wanted total. I think that's it for the pressures. Oh, yeah. And then we want the velocity. That's the velocity. Oh. Now we're gonna plot the the plots. And heads up, if you do these contours, see how I showed like the 4 different graphics? You're gonna have to, I guess they might show up here, actually. I never thought of that. No, never mind. You have to actually click this to save the 4 different images. So keep that in mind. Open up the plots. We're gonna create a new surface. So we're gonna go along the line of the along the line of the entire wind tunnel. And basically how you would do that is divide the length, add up the lengths of each individual section, and then divide it by 2. And the correct value is yeah. And they're in meters, mind you, so your lengths are in inches, so you have to convert it back. Oh, 4. No, sorry, that is incorrect. Later 1.1811. No. 1.1811. Hit create, and then select it. So then, so that's basically it. You're gonna get your static pressure. Just go through and change it. We want dynamic too. Dynamic, total, and then we wanted the velocity. Same thing. So yeah. And in that, you want to switch it to Y and float and apply that. So if I go back through that, static, dynamic. Total. Yeah, I think that all that does is changes the scale of the chart. And then again, velocity. So that gives us the second bullet point or second. I think it's a second. Yeah, and I think it is. So then let me check just to be sure. Yeah, so the next one is the distribution at the center of the test section. So to do that, what we'll do is create another curve. No, sorry, not a curve, surface. This one's gonna be a rake. And basically what a rake does, it's like taking an integral and you make a section. And we need to make it in the inlet, test section, and the outlet. So you have to measure from the origin to those numbers and then make a fractional area of it. So for let me make sure I'm going in order. Okay, for the outlet, I'm going to do this. And then you make it smaller, so it's like an area. Create that one. Then we have inlet. I'm sorry, this is for the fourth bullet point, but I'm just gonna go through and finish it. Chamber. Yeah. Okay, so disregard these for right now. Still gonna go to new surface rake. But so we just need the the graphs in the test section. So what you do there is you're basically gonna take the length of the test section from the beginning to end. And you would put that in Y because we want the center of it and the x naught at x0 and 0 it's already in the center because it's at the origin. There we go. So we don't want that, we want that. And then you're gonna flip these. Yeah. Just flip them. So yeah, that's velocity, pressure, static. Yeah, these are right. Pressure, dynamic, and then not absolute. I made the mistake earlier. You don't do absolute, you do total. Okay, so then for the fourth bullet point, so now we're done with the three because those are all the graphs and the contours. The fourth, what you're gonna do is go to File, Export, Solution Data, and then I don't know what that stands for, but that. And then you're gonna do let me go to so I know which one it actually is. So for pressure inlet, it's static pressure. You're gonna write it, save the file, and then you would go into Excel and input it'll open up it as a notes file. You would copy and paste it in there. Let me give an example, I guess. I don't really know why we need to do this, but let me just, so, okay. So we have the inlet. The outlet is still dynamic or static. And then, oh, guess I already have that. And then the test chamber is dynamic. You see. Then you would you're gonna go to open up an Excel file. Of course, it opens on my other monitor. And then you're gonna go to documents and try and find, I'm not sure where that's saved, to be honest. Downloading? No. I'm looking. Ah, I found them. So I'm just gonna give an example. I'm not gonna go through and do all this. So this is the inlet. You're just gonna copy. I just copied to 100 because like 100 iterations of data. And then inlet, and then you convert text to column. Then you do the same for outlet. I'll just do the example for, I'll just do it at this point. Same thing. It's on my other monitor, but I'm doing the same thing, opening it up in Notepad. And same thing, convert. I have to laminate it, fix. And then test. Test. Yeah. Oh. I'm copying the data right now. Okay. Same thing. Column. I don't really think we need to show this part, but I'm just gonna do it to be sure. So then you take the difference of them. That's what it asked for in the graph or the project. So you just make a simple equation. It's inlet pressure minus outlet, and it's negative to become positive. And you just grab this down. I'm only gonna go to 90. That's where it ends for that. Then you just insert a chart. Scatter plot, of course. Yeah. Select data. This is the data range you need. Stop there. Get rid of these. Should be fine after that. Yeah, so this is your which axis does it want it? Get. Yeah, so this is right. Difference versus dynamic pressure. and then you'd add spaces in the way. You would add trend line. It's definitely linear. I just displayed the equation. Yeah, and that's really it. And then you, of course, you do that 3 times for each frequency with the different velocities. And same thing with the graphs and the contours. So, yep, that's it. I think we only had to show one though. So, yep, this is my project. Thank you so much.